Hi, everyone. Welcome to my talk, moving from Node.js to Dart. In the end, if you guys are lucky, I'll actually fly on a bird. We'll see about that. So this talk is about my personal experience in taking a production Node.js API and moving it to Dart. This API isn't large scale. It's not serving millions of users. It's just a personal app that we had, a stock simulator game, and why we moved to Dart and our experiences. In my opinion, Dart is a really powerful VM and it's a really amazing syntax. I mean, that's why I'm here. So using that for API development is pretty cool. What are we going to talk about? We'll talk about Node.js or Dart, the pros and cons and the differences in moving from Node.js to Dart and the frameworks and differences there. We'll talk about thinking in Dart. This is interesting because it's a really different paradigm. So we'll talk about how to really think in Dart when you're coming from Node.js and utilizing Dart's most powerful features for API development. Next, we'll talk about debugging in Dart. I'm not a perfect developer. I have bugs, so Dart really helps out with that. And lastly, most important part, getting it out there. So how to deploy a Dart application to an Amazon cloud. For that, a little bit about me, because I don't think anyone knows me. Pardon? Oh. I'm an entrepreneur and engineer. I've been writing APIs for the past 10 years in Cold Fusion first, Node.js, and now Dart. Anyone done any Cold Fusion development? Yeah, those are my homies. Cold Fusion was amazing back in the day, and now it's... I've deployed many large-scale Node.js APIs. I've written recommendation engines, real-time chat servers, and stuff. So it's kind of cool. I've done a bunch of stuff there. I'm also an Android and sometimes an iOS developer. I come from a Flex background, like many of you here, which is really weird. And fun fact, I actually wrote Flex 2 in action way back in the day. So I don't know if anyone read that. And I've written a handful of Dart web projects for clients. These are not API projects, just like Dart Polymer. And that's when I really started getting exposed to Dart and enjoying it, how well it is. Because I was doing lots of JavaScript stuff, Angular, JS, and just jQuery stuff, and it was driving me crazy. Lastly, but not least, I work in an amazing company called League during the day. That's where I do lots of Android development, completely separate from Dart, but threw that in. So let's take a look at the backstory. Let's get the animate in, perfect. So this is a game. It's called Market Wolf, and it's a native Android stock simulator game. If anyone wants to learn how the stock market works, you can download this and play it. It's by no means full-featured, but it's just a fun game, and you can compare with each other. If you and your friends are on there, you can see, hey, I made $1 million, you suck, all that stuff, right? Originally, it was written in Node.js. It uses RethinkDB as its data store in the back end. Uses lots of WebSockets because we're scraping stuff from Yahoo's stock ticker stuff and pushing it to your clients. So all that stuff has to happen in real time. Pseudo real time, it's every like 2 seconds because we're not going to pay NASDAQ for all those stock ticker quotes. And it's a medium-sized API. It's not tremendously large, but it's not like 3 lines. It facilitates a lot of stuff, like when you're buying stocks, selling stocks, searching stocks, figuring out, setting up stop limits and all that crazy stuff. And now it's powered by our Dart API, which is why I'm here. So let's take a look at a live demo. And what's crazy about this demo is I actually logged out of the application. So this is going to be a bit interesting. Alrighty. So everyone can see that. I'm going to start Market Wolf. I hope everything works. So here it is, the login screen. So now all this is being powered by Dart in the backend. So when I hit sign up with Facebook, what we do is we get the user's Facebook credentials and send over that auth token to Dart. And then on Dart, we authenticate the user, see if he's registered and all that fun stuff there. So I'm going to hit it, fingers crossed. Hopefully it works. Boom. All right. So now we show a little FTE. Unfortunately, the stock market is actually closed when I'm giving this talk. So what I did was I just rigged up our server to send out random stock quotes. So which is why Amazon is fluctuating like crazy right now. And so all that will work. And now I can hit start searching for stocks. So if I'm searching for Google, you can see it's happening real time. That's our WebSocket stuff. Whoops. Google coming in. I can hit it. It loads up the Google stock thing. I can read a bunch of news if I'm interested. And then I can buy stock. And all this is happening using a Dart backend. Hit buy stock, it goes and creates an account. And yeah, there we go. And I'm also the most important part of this is I'm able to compare my net gain with all the other users on the system right now. So you can see Tofik has lost a lot of money. He's in debt, whereas I made $5,000, and I think that's just because I rigged up this entire thing. It's insider trading. So so that's basically the application. So it works. It was great. We actually built the Android app about like 6 months ago, 7 months ago in our free time, and we launched it as a different name. It was called Stock Market Simulator back then. And then I started doing a lot of Dart development. I said, you know what? The Node.js API is good, but there are some difficulties in it. So why would I want to switch from Node.js to Dart? Number one was the tooling and debugging support for Node.js is a pain. Yeah, there's WebStorm and stuff, but it's not as great as once I started using Dart development. Dart felt good. Node.js didn't feel right. I was already using Dart and Polymer and stuff, so I knew the Dart syntax. I liked it, and I wanted to learn more on how I can deploy this on the server. Has anyone done any Dart server development here? A few people. OK, great. So, and Node didn't seem to be the right answer. And the reason why is our API, there's a WebSocket component, there is a real-time stock fetching component, and there's a real-time leaderboard updating. So if I kept the application running, every 5 seconds, a leaderboard updates with my current portfolio, and everyone can see how much I made, and the next instance, I lost all my life savings. So that's all that's happening. With a single Node.js instance, which is single-threaded and running in an event loop, stuff starts blocking because you are getting a lot of stock quotes, parsing them out, and putting into our data structures and all that stuff. So the architecture we came up with for Node ended up being a 3-instance node where they're all talking via message broker. We had one instance that controlled the API, one instance that controlled the real-time fetching and stuff, and the other instance that kept the Redis leaderboard up to date. It was fine, but again, our application, we're not building a massive game. We're just trying to build something for fun. I didn't want to maintain 3 servers or have a message broker dependency and all that stuff. So with that in mind, I started looking into Dart and see how can Dart relieve my pain there. Boom. They both had to win my affection. The investigation was interesting. I started looking into it a lot, and I discovered that just doing Dart on the website, and this was before Async Await came out. Actually, this was just when Async Await came out, so doing Dart web development before and then coming to Async Await on the server side and stuff was really great, because I'm looking at Node.js, and there's a lot of callbacks. So anyone that's done Node development, we end up using promises. Promises are OK, but you still end up having this column of then, fail. So it worked, but it wasn't amazing. And then when I started looking at Dart's Async Await, it felt great. It felt like I was writing blocking code first. So I actually had to get my mind across it that this is actually going to work perfectly fine because the syntax is that amazing. And right, so before I get into the differences, let's talk a bit about the similarities between both platforms. They're both great platforms. I'm not putting Node.js down. Node.js is absolutely amazing. Lots of large companies are using it. And Dart is equally amazing, right? Lots of large companies, as we saw in the sessions yesterday, lots of companies are using Dart too. And the benchmarks, they're both pretty good. You can't say, oh, Dart sucks, Node.js is faster, Node.js sucks, Dart's faster. They're both equally. Sometimes Dart's good, sometimes Node.js is a bit faster. They're both equal. So I wasn't afraid about, or I didn't care about the benchmark stuff. I just cared about the language and what it offered me. Both are single-threaded and event-based. And you might notice an asterisk beside the single-threaded, and we'll get to that in the next slide there. And both install and run with a very, very low memory footprint. This is not Cold Fusion, where I have to get a whole server up and running and hope to God everything works fine. My actual application ends up being 200 megs. And they're both JIT compiled, so everything runs fine. All this stuff looks great. To me, Dart and Node are equally the same in that aspect. Differences, though, are interesting. It is a different programming paradigm. Dart is object-oriented, class-based, and Node.js is JavaScript. All the craziness, all the craziness that comes with JavaScript. Node.js, if you want to take advantage of multiple CPUs, you have to run multiple instances of Node and behind the load balancer. So when I built a real-time chat application, that API was clustered on the 16-core Amazon CPU, and we had a load balancer in the front, and all of them talk perfectly fine. But when you look into Dart server-side development, you can do the same thing. At the same time, you can use isolates. And isolates lets you run one node via one Dart instance and get multiple single threads running on multiple CPUs. And we'll get into isolates in just a sec. This was a personal thing. There's no forever tool to restart Dart servers when they crash. Node.js, you kind of spoil. As soon as something crashes, you just restart the whole thing and hope all the memory problems are gone. Dart doesn't have that, but it's really easy to build, and I'll show you in a sec. So with that in mind, I said, all right, great. Dart and Node seem good, and I'm leaning towards Dart, so I might as well just write a pros and cons list just to see if I'm going in the right direction. Pro for Dart, it's better profiling and debugging. I'm using WebStorm, and it is absolutely amazing. I can step debug, and the entire IDE is great. Everything looks fine to me. And the biggest thing is observatory, right? Node inspector, when you're actually profiling Node applications, is only so good. Observatory is like, dang. Another pro is syntax and language features. This is a personal preference, and I'm sure everyone here shares the same preference. Dart's syntax is great. Dart's language features are great compared to JavaScript. Another one was organization of code is better and enforced. So sure, you have in Node, you have modules and stuff, but Dart, you have classes, and you can extend classes, and all that really, really fun stuff that keeps your application sane, and even in your mind, keeps everything very logical. It supports all major databases on pub.dartlang. You can find a driver for most, if not all, databases, with the exception that there are some really esoteric databases that come out yesterday that you won't find Dart support for, simply because they're building Node.js drivers, but don't trust the database that came out yesterday. Now this is a pro and con, and I really realized this when I started talking to my friend who's helping me build this application, that there is a shift in thinking when you're coming from Node. You're not thinking like JavaScript anymore. You're thinking class-based stuff. You're thinking about async await. It kind of takes a bit of getting used to if you're not so familiar with that type of language. And we just talked about esoteric. So going over all this stuff, I'm like, all right, you know what? I think I'm going to go with Dart. And I clapped and I danced around a bit, and I said, okay, now what? Now's the hard part. I actually have to port the code over. So the application, initially, the Node.js application was written in Express. And Express, if you don't know it, is like the most popular and powerful framework in Node. Almost everyone uses it. And so I wanted to find the Express alternative in Dart, because I just wanted to make that migration easy. I didn't want to come up with a whole new way of writing API routing and stuff. So there's actually, I found 3 promising alternatives, but there are countless other alternatives there. The 3 that I found were Redstone, Shelf, and RPC. Now let's talk a bit about Redstone first. Anyone here use Redstone in the past? Okay, a few others. Okay, cool. So Redstone is a API framework like Express. It's actively developed by the community. It's very, very expressy, and we'll take a look at the code snippet in just a sec. It's good community support for middlewares and plugins. So there's a Postgres SQL mapper, there's a MongoDB ORM mapper, session management stuff, a static HTML, a server. So it's pretty expressy. If you take a look at the code, here's an Express code snippet, very easy to understand, but messy because it's JavaScript. And here is Redstone, right? Even a preschool kid can go, hey, look, they look really similar. So Redstone is really similar to Express, and in my opinion, it is the Express of the Dart world. And so it's really clear. It's also easy to understand, and there's good community support. So if you run into issues, you just ask on Stack Overflow or just go to the GitHub issue page, and people will answer and help out. But I didn't want to just go, okay, Redstone, I'm going to use it, forget about the other two. I wanted to check my options. I don't want to make a mistake. So I took a look at Shelf. Turns out Shelf is actually built on, Redstone is actually built on top of Shelf. So Shelf is the base of Redstone. It's very minimal. It's not actually an API framework. You can use those components to build an API framework really easily. It uses, it doesn't have routing. So if you want to use routing, you have to use a third-party middleware, or I think it's provided by Shelf. And a bunch of Redstone's middlewares are actually Shelf's middleware. So if you are using Redstone, you can get all of Shelf's middlewares running there. And it's a simple API, so let's take a look at an Express example. That's how Express is. And if we take a look at Shelf, that's how Shelf is, right? Again, very simple. So if you don't really need all of Redstone's powerful features, you just want to build a very bare bones API, then go with Shelf. It's easy. And it's also made by the Dart team, so you're not going to go wrong there. The last one that I found was RPC, and this was an interesting one. RPC is a package for building RESTful server-side RPC-style APIs, and it's the newest one of the two. It actually just went public a few months ago, I think. And it's interesting because you can write, when you write an API, it's very self-documenting, and that's what I loved a lot. You're using a lot of annotations, kind of like Shelf, but you're adding a bit more information to your API. So if we take a look at Express, again, we're all going to use that example. Here's the RPC example. You're importing a toy API.dart, and we'll take a look at what toy API is in the next slide. And then you got API server, you're adding it, and you're setting up a discovery API, and then you're just saying, hey, I'm listening on port 8080. Toy API.dart is just a class that you can have your gets, puts, posts, all that stuff there. And it's very easy, and you can see that it's very descriptive. An Android developer, like the developer that built the app, can come on and be like, okay, that's the actual API. I don't have to generate lots of documentation for him. So it's a bit more verbose. It's not as clean. It is clean, but it's not as short as Redstone or Shelf. But I think I like it because it's very self-documenting. One great feature about it, though, that you can generate client-side libraries using Google's Discovery document format. So you can have client-side libraries for Java, Python, a bunch of crazy stuff. And it's great. And again, it's made by the Dart team, so you can't go wrong there. I went with RPC. Next, the requirement here was we had this Socket.io server pushing stock quotes to the Android devices. So we had to find a Socket.io alternative for Dart. Luckily, we don't have to go far. Dart comes natively with WebSockets. This was an amazing feature. All I had to do literally was, I think it's the wrong code sample. All I had to do was new WebSocket, and it worked. This is, no, actually it's the right code sample. This is WebSockets integrated with Dart RPC. So I'm listening to RPC, then I'm saying, okay, if the web request path is WS, then pass that to the web transformer upgrade, and then handle all the messages that come in through the socket. Done. We had WebSockets working. We had the API working. Great. So how do we get them all together, actually write all this stuff? Yes. OK, so thinking in Dart. This was the most key thing that I discovered while writing MarketWolf in Dart. Our basic API, just to reiterate, our basic architecture was we had to fetch stocks in real time. We had to keep the leaderboard updated in real time. And we also had to serve all the API requests. Node's single event loop didn't like that because there's lots of processing happening at every event loop. So we ended up splitting it into 3. Here is the architecture again, if you guys forgot. 3 stuff there. But in Dart, it's very easy to replicate that. I can literally just run 3 Dart instances, put a load balance in the front, everything works. But I found out about isolates, and that just changed my entire way of thinking. Isolates are pretty interesting. Every Dart application runs in an isolate. So when you first run an application, that itself is an isolate. An isolate is an independent worker that runs in its own memory, so you can't have variables being shared. But if you do want to talk to other isolates, you can talk to them via send and receive ports. What's great about this is we took those 3 cores, and I made that into 3 isolates. I had 1 isolate serving all the API stuff, 1 isolate for the stock fetcher, and 1 isolate for the real-time stuff. all of them were running on one VM instance, but on 3 cores. It actually made ops a lot easier. I just had one server. I didn't have to deal with load balances or anything like that. Here's how you just talk to an isolate. You create a new receiver port. You spawn an isolate. Service isolate.leaderboard service is actually the method that's going to run inside the isolate. That has like a for loop, I think, or a while loop, just fetching stocks constantly. And then I start the isolate up. This fit perfectly with our design. So if we take a look at our node architecture, and now our Dart architecture, it's all very self-contained, very nice. It works perfectly fine. And each isolate takes a very, very low amount of memory, just 1.5 megs. And it's lightweight enough to do the job well. And I've heard that the Dart team is improving the API, going to make that even smaller. So it's no cost to running isolates. What's cool is that you can listen to isolates get created and die. So if we go back to that forever in Node, where whenever your Node app dies, you can restart it, you can actually just listen to your API isolate or any of these other isolates and go, hey, did you die? Why did you die? Okay, I'm going to restart you. So you can have this constant, as soon as it crashes, restart the app again, send out a crash report, whatever. You can do all that stuff. You can also scale across multiple servers, right? There's nothing stopping you from taking this and creating 4 other servers and putting inside a load balancer. Isolates just logically they make clear sense to me, and when you're writing code, it actually works really, really well. Isolates are a game changer when you develop. And imagine if you're doing long-running database operations, you can just launch an isolate. It does its stuff in the back, and then just goes to sleep. So now we had all this working. I was happy, but then we ran into bugs, unfortunately. So, or fortunately, actually, because in Node, console.log becomes your best friend. All you do in Node.js is console.log. And then as a last resort, you'll set up like breakpoint debugging or go to Node Inspector and try to figure all that stuff out. So especially when you have a memory leak, you're kind of out of luck on Node. You guys set up a Node Inspector, really find out what's happening there. But we had a memory leak with our stock fetcher. Something was leaking. Luckily, Dart comes with Observatory, as everyone knows, and that made the process of debugging so much easier. And what's great is you can look at all your isolates in this memory map. So I didn't have to look through tons and tons of stack trace to find out where my isolate was being executed. All I had to do was just click on, okay, here's my stock fetcher isolate. Let's see what's happening in there. I can also see all the memory stuff for an isolate, see how much memory it's taking, see what's taking a lot of memory, how much is free, how much is not free. See the heat map, the allocation profile. So we ended up having where the hash map that held onto the stocks kept increasing. We weren't clearing stuff out. It was getting way too large. So, using Observatory, we solved that in like 10 minutes, and then we could get back to dancing around. So debugging in Dart was absolutely amazing. Everything was ready to go. We were about to launch this, and we were like, okay, we forgot a step. We actually have to deploy it to a server. So how are we going to deploy it to a server? Originally, the application used AWS Beanstalk. So the first thing I did was log on to AWS.com, get a new instance for Beanstalk, and then get bummed out that it says Node.js, PHP, Python, but no Dart, right? However, implicitly, it did say Dart. It said Docker. And what's great is that you can run Dart on any server that supports Docker. Because the Google team, I'm going to skip a bit here. The Google team has already built a Docker image for us to deploy on Beanstalk. If you don't know what Beanstalk is, Beanstalk's just a really easy way to run your application on Amazon's cloud, and they'll handle all the provisioning, scaling, load balancing for you. So you don't have to set all that up. You just have to create servers and tell Amazon, these are the servers I want you to use. Go nuts. And so Amazon will do that for you. So Dockerfile is really simple to use. It's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines, and you got your application ready to go. I import from Google/Dart. I create my working directory. I add the pub spec. I add all the files. I do pub-get, and then I expose the port on 3030. And then I tell Docker, when you run, call bin/server.dart. Now that we had that ready, there's just one more thing that you need to do on AWS. You need to create a DOCKERFILE.AWS.JSON. And what that tells AWS is, hey, my Docker instance is going to run on port 3030, so keep that in mind when I'm deploying. So expose the port, set up the right firewall configurations, load balancing, all the crazy stuff they do. Once you have that, really, it's just a matter of using their AWS command line tools and typing in EB deploy. It's the most simplest way to deploy a Dart application, in my opinion. EB deploy, it uploads it, runs it, everything's great. Alternatively, what you could also do was use a service like a continuous integration service like CodeShip, which is what I ended up doing. I ended up writing a bunch of unit tests, and whenever I do git push, origin, master, or whatever, CodeShip would pick that up, figure it out, run its unit tests on it, and once that's done, it would automatically deploy to AWS Beanstalk with the right Docker file and Docker AWS. So there was this continuous loop of continuous integration and deployment. That's actually what I did like 10 minutes ago when I had to make sure the stock stuff was all dynamic and random. Was all this worth it? Apparently not. All right. So was all this worth it? You know, I think it took us about a week to do this. Not a lot of manpower, but you know, really, we took already something that worked and just moved it to Dart. I think there's no question about it. Dart syntax, the language features, isolates, observatory, all that really, really cool stuff made a compelling case to move to Dart. Like when I look back on Node.js code, it feels like I'm writing assembly, right? It's just very archaic now. There's lots of callbacks, stuff's all over the place, and it just feels weird. Do we find anything missing that we go, okay, I wish Dart had that, Node.js does? Absolutely not. Everything that we needed in terms of the packages, the tooling, the support, the language features, everything's there in Dart. Whereas there's stuff missing from Node. And the number of lines of code shrunk dramatically too. Yeah, I think that's because of all the callbacks and stuff, but also because stuff's easier. We don't have to import a lot of dependencies and set that up. Socket.io is a dependency, so you have to set that up. In Dart, it's just new WebSocket. And there's a bunch of other examples where it was just really, really simple to get Dart up and running, whereas Node, you had to import a few libraries just to make that code more sane. In short, moving from Node.js to Dart was the best decision we made. For us, all API projects moving forward will be written in Dart, so any new cool thing I do, that'll be in Dart. Thank you.